Welcome to the Astro Guy podcast. I'm your host, Wayne Zuhl, and I really wanted to do something for my fellow astrophotographers. Whether you're just starting out or experienced, I hope that you'll find this helpful or even interesting. In this episode, we're going to explore how I was able to take a series of images to capture Bode's galaxy, known as M81. I'll outline the equipment used, the process in capturing, as well as stacking and post-processing the image to come up with a final image. So stay tuned, it's going to be fun. Enjoy. Welcome to the Astro Guy podcast. I'm not an expert, I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem, seize the night. Besides being an amateur astronomer and host of this podcast, I really enjoy astrophotography. In 2020, I got back into the hobby of astrophotography after a long break from it. By long, I mean that before 2020, the last time I did any serious astrophotography, film was involved, and the year started with a 19. So as the technology changed, the hobby of astrophotography has become much more accessible and, dare I say, affordable than it used to be. Now that I've been actively pursuing astrophotography for the last 3 years, I've learned a lot, but I'm no expert. I've relied on doing a lot of research to learn about the hobby of astrophotography. I've read articles, books, and I've gotten a lot of information from various websites and YouTube channels. Channels like Cuiv, the Lazy Geek, AstroBackyard, Nebula Photos, Lukamatico, Visible Dark, and others have produced excellent videos on the subject. And I'm not looking to do what they do. But I'm happy to share my experiences, along with what I've learned from them as well as through trial and error, and hopefully you'll gain something useful from it. So being the spring, which we often refer to as galaxy season, I thought that I would make a project out of capturing and processing an image of M81. First, I needed to decide which telescope to use. For this particular project, I used my trusty old Celestron 8-inch SCT, paired with my ZWO ASI 533 MC Pro camera. However, the field of view would be too small to fit the whole galaxy on the sensor, so I added my Celestron 0.63x reducer flattener to the image train. This also meant that I would need to make sure that I had the correct back focus, in this case 105 millimeters, which was achieved using spacers. One of the spacers is a filter drawer, which allows me to use different light pollution filters to help bring out the galaxy, as well as the H2 regions within it. My C8 is just an OTA, or optical tube assembly, and I mounted it to my Skywatcher HEQ5 Pro mount. This requires using 22 pounds or 10 kilograms of counterweights. In addition to the scope, reducer, filter, spacers, and camera, I mounted my ASIAIR Pro to the scope, along with a 50 by 200 millimeter guide scope. I chose my planetary camera, a ZWO ASI 462 MC, to work as the guide camera. If you're not familiar with guiding or auto-guiding, we'll get to that in a bit. I use a few other accessories as well. A ZWO EAF, which is an electronic autofocuser, a Celestron dew heater ring and controller, to keep dew from forming on the corrector plate of the C8. Of course, USB, Ethernet, and power cables are all connected as well. The first step after get everything mounted and plugged in is to make sure that it's well balanced. First, I loosen the right ascension clutch and move the scope to one side as I make small adjustments to the counterweights until the scope can be moved and then stay still once I let go. I do this on both the east and west sides of the mount. Once the scope is well balanced in RA, I'll rotate the RA axis so that the counterweights are on the west side of the mount and parallel with the ground. Then I'll lock the RA clutch. Now I have to balance the setup on the declination axis. So for this, I just loosen the deck clutch while gently holding the scope. If the scope is front heavy, I'll lock the clutch and move the scope a small amount backwards in the mount saddle. If it's back heavy, I'll move the scope forwards in the saddle. I'll keep making small adjustments until the scope stays level. Now I'll point it straight up and make sure it doesn't move with the clutch loosened. I'll do this at several points along the meridian and make minor adjustments if necessary. Once the scope is well balanced, you should be able to loosen both clutches and the scope stays in position when you let go. Test this in several positions, then return the scope to the home position and lock the clutches. Now the fun really starts. Once it's getting dark, I'll make sure the mount is level and pointing roughly north. I'll open the ASIAIR app and connect it to the ASIAIR. Now, using the camera controls in the app, I'll set the temperature for the camera's cooler. In this case, minus 10 degrees Celsius. This helps reduce the digital noise in each subframe and will make for a cleaner image at the end. Now, using the mount controls in the air, I'll find a bright star to do a rough focus. This will make polar alignment much easier. Usually, I'll just take a 3 to 5 second exposure to see if the stars look sharp. I'll do this several times while making adjustments to the EAF in the app. Focus doesn't need to be perfect at this stage, but you want to be able to have stars that look fairly well focused so that the AIR can plate solve them. Now, using the mount controls in the AIR, have the mount go back to the home position, assuming that you can see the pole. If you can't see the pole, the AIR has a different routine to follow, but it will prompt you on what to do. Fortunately, where I set up, I can see Polaris. In the AIR, change from the Preview to the PA or Polar Alignment tab and press the play button. The AIR will take a picture, plate solve it, and then you'll be prompted to go to the next step. Click Next and the mount will now rotate about 60 degrees in right ascension. Now it will take another picture and plate solve it. In a few seconds, there will be a Go button on the screen. Click that and then check the refresh box and click Auto. The AIR will take continuous short exposures, plate solve them, and let you know how far you're off in altitude and azimuth. Next, I'll make a series of small adjustments, first to the azimuth axis of the mount by adjusting the two knobs on the north side of the mount. I try to get the azimuth as close to 0 as possible. I always shoot for an error of 30 arc seconds or less, especially with the C8. Then, I'll do the same thing on the altitude axis. After each small adjustment, wait a few seconds for the screen to refresh so that you can watch your progress. Once you're happy with the polar alignment, click Done and go back to the preview screen. Now that the mount is properly polar aligned, I return the mount to the home position using the AIR, and then I'll have it go to a bright star, usually within about 30 degrees of the celestial equator. Once the AIR centers on the star, I'll run the autofocus routine. After the scope is focused, I'll have the AIR move the scope to the zenith, and then I'll stop the tracking. Now, I take my flat frames using a flat panel, which is just a USB-powered tracing board and some paper to diffuse the light a bit. Next, using the auto-run flat setting, I collect 30 flat frames. Using this method lets the AIR choose the correct exposure for the flats. After that finishes, I'll put the cover on the front of the scope, and using the same exposure time that I did for the flats, I'll take 30 dark flats. Taking calibration frames is a quick and easy task that will eliminate all kinds of issues like dust or vignetting from your final stack. If you're shooting over multiple nights on the same target, make sure to take calibration frames for each session. Once the calibration frames are captured, I'll clear the auto-run settings and set up my plan for the light frames for the evening. For this project, I shot 1 minute, 3 minute, and 5 minute exposures. Now, send the mount back to the home position. Now you can get set up to guide, and then get ready to image. So the first thing we need to do is go back to that star that we used for focusing. Remember, it was a star within 30 degrees of the celestial equator. Once the star is centered, open the Guide tab. Now, on the Guide screen, you want to click the looping button, which looks like two arrows going in a circle, and then the calibration button, which is right below that. At this point, once that's done, I'll go to the auto run screen and click the hamburger. From here, I'll clear whatever's there and I'll add a new sequence. In this example, I'm telling the ASIAIR to take 60 300-second exposures. I'll confirm the gain and the temp settings, click OK, and exit back to the main auto run screen. By now, the ASIAIR and the mount should be finishing up the calibration process, which usually takes about 3 to 5 minutes. You'll know it's calibrated when you see the red and the blue lines moving across the guide window. Once it's guiding, I'll have the mount go to the target, in this case, M81. The scope will locate and center M81, and then guiding will resume after just a minute. Once the guiding has started back up, I go to the main auto run screen and hit the play button to start the sequence. My typical guiding settings include dithering after every 3 frames for my 5-minute exposures and after every 5 frames for shorter exposures. This will eliminate walking noise, which are diagonal lines of noise on the final image. Dithering is very important in getting a good final image, and if you dither, you'll be able to drizzle later in the processing stage. I'll explain that as well. Now, I get to go inside and watch the progress on my tablet. In the course of the evening, the ASIAIR will likely refocus a few times due to temperature changes. I usually set the EAF to refocus for every 2-degree change in temperature. For this particular project, I repeated the process with varying exposures and 2 different filters. After 4 nights over 3 weeks, I acquired just over 8 hours of data. Now it's time to stack the images. Using the ZWO viewer on my PC, I can also do this in Pixinsight. I'll go through every frame and discard any bad frames due to clouds or poor guiding. If you take enough frames, at least 100, you don't need to worry about planes or satellites, unless you capture a plane that's pretty low and you get the strobe going off. If you don't see that, you should be okay leaving them in the stack. The software will remove them. I like to use Astro Pixel Processor for stacking my images. It's easy to use and it has some great features, like extracting hydrogen alpha data from one-shot color images. In some instances, I've extracted the H-alpha data and incorporated it into other data. It's a bit more of a complex procedure, and there are great videos out there describing how to do this. But for simplicity's sake, we won't go through this here. First, I'll stack the images from all the different sessions together. To make the stacking process a bit simpler, load the image from each session one at a time, and then assign a name for that session. I change the name to the date that the images were taken. Then I'll load the calibration frames for each session and assign them to the proper session name. Astro Pixel Processor will add the calibrated images from each session into the final stack. In the integration settings, I set the integration mode to Bayer X Trans Drizzle, and then I set the scale to 1.5. This is the drizzle that I had mentioned earlier. Drizzling allows you to increase the resolution of your image, in this case by 1.5 times. So my roughly 3000 by 3000 pixel images will integrate into a single stack that is about 4500 by 4500 pixels. If you didn't dither, and you did this, you'll likely end up with square stars. Drizzling is achieved by an algorithm that was originally designed for Hubble Space Telescope images as a way to increase the resolution. Hubble dithers just like we do in astrophotography. Combining dithered frames with drizzling will yield nice round stars and better overall resolution. When stacking over multiple nights, there's bound to be some overlap of the images, but don't worry, we'll crop those out later. Now that all the stacking is done, it's time to move on to Pixinsight for post-processing. Alright, so what I'm going to do now is walk you through the process in Pixinsight, and I am no expert when it comes to Pixinsight. I've been using it for about 6 months, and I'm pretty confident that, or I'm pretty capable, I should say. This is the stacked image after it came out of Astro pixel processor, and because I shot over multiple nights and I dithered, there's a lot of strange artifacts in there. Hopefully you're watching this on YouTube and you can see these lines here where the frame was a little bit off. So we need to use dynamic cropping to clean that up, and I'm just going to show you how we do that real quick. I like to maximize it just because it's a little bit easier to move this, and I'm going to kind of bring it like that and that. And I actually have a cropped version already that's set to work on the images, so I'm just going to show you the process here, and then you just click check, and there it is. It's a cropped image, but I'm not going to save that. I'm going to keep it the way it was. So this is the cropped version here. So here I cropped away the stacking artifacts, and now I'm ready to remove the background. That's the next step in the process. So clear the background up to get rid of the gradients and the light pollution. You can see it's brighter down at the bottom than it is at the top. We're going to use dynamic background extraction. So that's a pretty easy tool to use. I like to generate samples, and then you see some of them are covering the galaxy, so I'll go through one at a time and clean them up. I'll get rid of the ones that I don't want and go through that process, and I'm not going to take you through that because, again, that's a little time consuming, but I usually clear all the ones out around the galaxy. So the galaxy itself is not covered by X's, but the background is. And then I just change the target correction and subtraction. I normalize, discard the background image or the background model, and then I replace the target image. I would execute. So you press the check mark to execute the command. It goes through the process, and it's going to clear the background. There, I'll show you the before. There's the before. Now, it's not going to look as clean because I didn't. Let me show you the correct version. So this is before. I'll keep it like that. And then this is after I've done dynamic background extraction. So you can see the difference in the two images. The gradients are gone from the bottom here, and it's cleaned up, and the galaxy is still there intact. So the next thing that we need to do is color correction. And to do the color correction, there's two steps involved. First, there's a script that has to be run, which is the image solver script. And to do that, it's very easy. When that comes up, you want to search for your object. In this case, it's M81. I find it in its database. There it is. I click OK. And then I'm going to put the date that the images were taken. And it does this so it can use the correct coordinates. So it's 2023. This was taken on March 30th. And we'll say it was 10 o'clock at night. It was drizzled. So I'm going to, the pixel size is I divided the pixel size by 1.5 to get this number, and the focal length is right there, and I click OK, and it's going to go through and do its process, and it's going to plate solve the image. Now, one of the cool things about this, we can use this for color correction, but we can also use this annotate the image. So if we go to script and render and annotate image, it's going to create, it's going to bring up a script, and I'm just going to go with the defaults. And there it is. So then it gives me an annotated image of my image here, but we're not going to worry about that at this point. The main reason we wanted to plate solve the image with Image Solver was so we can do the spectrophotographic color correction, or SPCC. And the way we do that is we just drag the SPCC icon. I have these process icons here, which you can set up, or you can go up to the process window and run it from there. And what it's going to do is it's going to go through its routine, and it's going to correct the star colors. Now, when it does this, this box always comes up. You can get rid of it if you don't want it. It's just the white balance, so I always clear that. Now, one of the things is when you do an SPCC, it removes the auto stretch. And I don't know if I said this in the beginning, but I did an auto stretch on the image. So let me just re-stretch it. And there it is. And now you can see the image is cleaned up quite a bit. Although the colors now, everything kind of looks black and white, and that's it. but we're going to enhance the colors. If you look at it closely, you can see some very faint blues and reds, and we're going to bring those out in a few steps. So this is the color corrected image. So the next step in the process is to run Blur Exterminator. And you can see here the stars are kind of bloated. And Blur Exterminator is great at reducing the stars. And it's also great at bringing out some of the details. If you look in here, there's some nice details, but they're kind of faint and they look a little blurry. So Blur Exterminator is going to clean that up for us. For this particular image, I'm going to set the sharpen stars all the way to 0.5. I'm going to keep the star halos at minus 0.10. And I'm going to put in the PSF, which on this image I know is 6.45. And then I'm going to drag the triangle onto the image and run it. And I'm not going to make you sit through that, so I'll show you what it's going to look like. That does take several minutes on my computer. So this is what it looks like after Blur Exterminator. So you can see the stars are much smaller, and I'm going to do a before and after here. So here's after and before, after, before. So the stars really are really affected. So before earlier I showed you this area right here, where you see the dust lands here. Well, let's see what those look like after it's cleaned up. Wow. All right, let's just move that a little bit. So the stars are much better. Here's before, after. Before, after. Hopefully you can see this on the video, but it really makes a huge, huge difference. So the next step is to denoise it. Now the image is noisy, and you can see as I zoom in, these blue and reddish and green dots and speckles, that's digital noise. It's all over the image. So what I'm going to do is use Noise Exterminator to clean that up. And for this, at this point, the settings that I use for that are 0.5 on denoise and 0.25 on detail. And you just drag the triangle onto the image, or because I have this set up as a process icon, I can just drag the icon right onto the image and run it like so. So here's the image after it's been denoised. Actually, this is before denoised. So I'm going to zoom in a little bit here, so you can really see there's a lot of noise in here. It's a very noisy image. So let's run Noise Exterminator. So this is the image before Noise Exterminator and after. Now there's still some noise, but it's much better than it was before. So before, after. And let's look at another area here. Here's before, after. Before, after. Before, after. Before, after. So it really does a great job getting rid of that noise. And we're going to do that one more time later in the process. Now, this image is just stretched with the STF auto stretch. It's still a linear image. And we're about to change that. We're about to go from linear to nonlinear. And the way that we do that, and this is the pre-stretched image here, and you can see that I've gotten rid of the auto stretch. And what I'm going to do is use general hyperbolic stretch to stretch the image. So there's a lot of different methods you can use. All right, so you can run easy soft stretch if you like, and that does a great job. It's quick. It does a good job. Brings out a lot of detail. I use general hyperbolic stretch a lot of times. Let me show you how that works. Let me just undo this. Bring it back to there. Go to Utilities and Generalized Hyperbolic Stretch. Once you have the Generalized Hyperbolic Stretch script open, you have to select the image that you want to stretch. So this is pre-stretch. That was the image that we're going to use. And it brings up a preview window, and there's no auto stretch on it. So the first thing we need to do is zoom in. And we're not zooming in on the image, we're zooming in on the histogram, as you can see here on the upper left. So what I like to do is I like to put the cursor somewhere right about the middle of the peak. And if it's a little bit to the right or to the left, that's okay, but you want it pretty close to the middle. And then you want to click the button that says send this value to the SP, which is the stretch point. So I did that, and I'm going to change the local stretch intensity. The author of this script says you should start between 8 and 10. So I'm just going to set it to 9. And then I'm going to take the local stretch factor, and I'm going to slowly bring that up. And you can see the histograms moving, and once it goes off the screen, I like to stop, and you can see the core of the galaxy and some stars just popped out. But we're going to stretch it a little bit more on this first stretch, and we're going to do a couple of different stretches. There, now you can see the core is well defined, the spiral arms are there. Contrast isn't great, but we're getting there, and there's a lot more detail. So that's good for a first stretch. So let's hit the checkbox to actually make that stretch. And once that's done, the whole screen turns white because it reran the stretch again. So you just have to hit the reset down here, and that resets it back to where it was. Now the zoom is going to be off because the image is stretched now. So the histogram is going to be a lot further from the edge, but we want to bring it out a little bit more. And this time I'm going to go just a little bit to the right of center. I kind of like to do it right about there where it starts a steep drop off, maybe even a little bit more. There we go. And I'm going to send that value to the SP. And now when I do it, I'm going to do the local stretch intensity down at around 3 or 3.5. Let's go 3.5 for the example here. And then I'm just going to move this a little bit, not much, and see what it does. A little bit more. And it's bringing out the details in the galaxy a lot more. But you can see if I go, I don't want to go too far. That's about as far as I'm going to go with this. So let's apply that. And again, the screen's going to turn almost white. We have to reset it. And let's bring the zoom back to 0. And that's what our histogram looks like now. But we're going to do a little contrast stretch. To do a contrast stretch, I'd like to set the stretch point kind of down here where really the angle gets very shallow on the right side. So once I put that there, let's send that value to the SP. And I'm going to set the local stretch intensity to about 2. There we go. And what this is going to do is this is going to start to increase the contrast. And it's bringing up the highs, bringing down the lows. And, you know, you can play around with this. You can play around with this and really tweak it quite a bit. I do have a finished version, so I'm going to stop at this point, and I'm not going to save the log, and I'll show you what the finished version looks like. So this is mine, the same image with the stretch that I'm using for the processing here. So the next step in this is we have to get rid of the stars. So there's a tool that Bill Blanchard has. You're going to hear me mention Bill Blanchard a few times in this video. He also has a great stretch tool that you can use. But using this clone for starless is great because what it does is it clones the image and names it starless. Now I have one already that's named starless down here, but it renamed it starless 1. But you need to do that for later in the process, and it makes things a bit easier. So this is the starless image unedited. Now what I had done was I ran Star Exterminator, and on this image it takes about 15 minutes to run on my computer, so it's very slow. I'm not going to drag you through it. But the settings I used were just generate star image, and I ran it. And I just dragged this on here onto the image with the stars, and after about 15 minutes, this is what I get. And it missed some of the stars. Now, if I had used unscreened stars, sometimes that will remove more of the bright stars. But because my collimation was slightly off, there's some flares on these stars, so it didn't know that they were stars and it didn't remove them. So what I did to get rid of that was I used the clone tool. And the clone tool is up here in processes, all processes, clone stamp, here we go. And I just click, hit control and click, and there, and I can change the radius, the size of the circle that it's going to do. I like to do 50. And here we go. Boom. See the stars, that star is gone now. Come over here and bang, that star is gone. Over here. And that star's gone. And then this big one over here cleaned it up. Now there's some stuff around the edges which you can clean. Same thing here. Like I said, this isn't the most ideal thing to do, but sometimes you just have to do it. And once you're done, hit the checkbox and bang, the image is saved and everything's all cleaned up, ready for the next step. So let me close that. And then again, here's the image all cleaned up, ready to go. So now that this image has the stars totally gone, we're ready to bring out some of the color in the image. So I have a process icon here, which is just a curves transformation, and you can see it there, and it's doing just the saturation. So I'm going to bring this over. I'm going to drag it over, and it's going to do its thing. And it sometimes I have to do this a few times. In this image, I know I have to do it 3 or 4 times. But now you're starting to see those colors come out, and you can do as much or as little saturation as you want. I don't think I'm going to go any more than that. I think that's pretty good, and we're going to make these colors really pop in a couple of minutes. So after increasing the color saturation, the next step in the process is to increase the contrast. And to do that, I just have some contrast adjustments set up. This is actually done with generalized hyperbolic stretch. It's just a process icon that was made for it, and I can bring that over and do that, 2 or 3, 4 times if needed. I have an additional contrast adjustment here, which is done using curves transformation. And I'll show you what this looks like once I do everything to it. Okay, so after the ASIAIR, there's a lot more red and blue in the image. So now we have to increase the contrast a bit. And I have a couple of different process icons for doing that. I have some, that's a small one there. That's a little bit larger. I want to go a little bit more. So I'll use the smaller one. That's pretty good. We can clean that. We're going to clean that up again at the end. I just made some slightly different adjustments. So now that we have our starless image, we need to work on the stars. And this is the image that was created by Star Exterminator. So the first step is here to increase the saturation on the image. And for that, I probably do it 4 or 5 times because, the star colors, you really want the star colors to shine. But you don't want them to be too much. And that's about good right there. You got a lot of blues in here. There's some reds. So that looks pretty good. So down here, we have the starless stars. Here's the image. I didn't do anything as far as noise reduction on the starless image. I didn't do anything with contrast because it's really black. But if the stars have, like some of the brighter stars, if there's green, you can run SCNR, and that's going to clean them up a bit. If there's magenta around the stars, you can invert the image and then run SCR and reinvert it back to a positive image, and that magenta will disappear from SCNR. It's a pretty cool trick. So this is what the starred image looks like. So now we have our stars and we have our starless image. Now we have to add them together. So we're going to use pixel math to do that. And pixel math scares people, but it's really not that bad. At least this is pretty basic. So you want to make sure use a single RGBK expression is checked. Open the expression editor. We're going to select the starless image by double clicking it, and then plus with the plus sign and starless stars. And then we're going to click OK, and I'm going to change the destination to create a new image, and I'm going to execute, and there we go. And there's our combined image. So now we have the starless image with the stars added. Even though earlier we used Blur Exterminator, which really helped clean up the stars, Bill Blanchard has some great tools, some pixel math scripts to reduce the stars even more. In this image, you have to have everything named properly using this script. So for this example, I'm going to change this number to 0.25 because I really want to bring the stars. The lower the number, the more the stars get reduced. And I don't want to reduce them too much, but I do want them reduced a bit. So I'm going to drag this onto the image. And it's going to do its thing, which takes a few seconds. There it is, and it's done. So let's look at, here's before and after. And the place where this really shines is this visual double here. It's still kind of noisy, but here's before, after. And again, zoomed out, before, after. So this is a great tool, and there's different versions. There's 3 different methods that you can do. They work. Some are better for galaxies, some are better for nebulae, but they work really well. It's a great tool. Okay, so the next step in the process is to do a dark structure enhance, which is a script. You go to scripts, utilities, dark structure enhance, and I just keep it on the defaults, and I click OK and let it run. Takes less than a minute. It's very quick. It probably takes less than 30 seconds. But in the time that I'm talking, it's going to do its thing, and we'll see how much of a difference it makes. Sometimes it makes a difference, sometimes it doesn't. So, okay, so it did make a difference here. So you can see here's before and after, and you can see the core of the galaxy get a bit dimmer. It's not really getting dimmer, but it's enhancing the darker areas. So the dust lanes really pop a bit more. So the next step is to bring out even more detail. And the way that we're going to do that is local histogram equalization. And you can set the amount to whatever you want. I'm going to start this at about 65 and see what that does. So change the amount to 0.65. I'm going to keep everything else the default and drag this onto the image. Pixinsight's going to do its thing. Again, this is pretty quick, but it takes about a minute to run. It does its thing in there. Wow, it really did a lot. So let's take a look at the before and the after. So here's before and after. And now it's really bringing out a lot of the structure in the galaxy. Again, before, after, before, after. So wow, now it's really taking shape. So the next step is we need to do some contrast adjustments. So now that we have the detail enhanced, we have to increase the contrast a bit. So for that, I'm just going to do a little contrast tweak, which I have down here, and bring it on in there. That helped a lot. Let's see, maybe one more. Okay, that's pretty good. I don't want to go any more than that. So you can see the image is still pretty noisy. So now we have to get rid of that noise. A lot of the processes that we did once we went nonlinear added noise to the process. And if I zoom in, you can really see it's still very noisy. So we're going to do another noise reduction. And this time I have the denoise set at 0.6 and the detail at 0.15. And we'll drag that over to the image. And noise exterminator is going to run, and it takes on my computer again, it takes about a minute to do its process. So I'll come back as soon as it's done. Okay, so now the image is denoised. So let's take a look at what it did. Let's see, before and after. Wow, huge difference. Still a little bit of noise, but it's not terrible, and we can tweak that a bit as we go. So the next step is we want to add, we want to just tweak the colors a bit. So we want to create some masks. Now, again, I mentioned Bill Blanchard a couple of times. He also has these great scripts, pixel math scripts, to create color masks. Now, there is a tool under scripts and utilities called color mask. You can go in here and you can actually choose, you can pick over here what color you want to highlight. So in this tool, I can highlight a portion of the image and say I want to increase these pinks here. I can go, let's do a magenta mask or a red mask, it looks like, because it's in that range there. And just click around a little bit on the reds, and you can see where, okay, yeah, that's definitely what we would do for a red mask for that. So I'll show you the red mask. And I'm going to run that. And again, it's doing pixel math to do this. So it's a script that does pixel math for you. Bill Blanchard does pixel math here as well. So here you can see it's highlighting things that have that particular red in a range there. And I like to blur the mask out, and sometimes I'll do 2 blurs, and that way the stars don't get messed up. So once you have your mask created, you just drag it onto the image, onto the bar here, and the image turns red. Once the image turns red, now you can do what you need to do. So for that, we're going to go into Curves Transformation, and we're going to go to the Preview and Curves Transformation, which is the little circle at the bottom. Make sure you've highlighted the image that we're working on. I like to maximize it. So what I want to do is I want to adjust just from that mask, and you can see what the mask is highlighting by keeping this on RGBK, just grabbing the center in the curves box here, and just bring it up. And you can see it's making the center of the galaxy a lot brighter. And if I pull it back, it dims the center of the galaxy. But the outside doesn't really get affected by it. So what we want to do is we want to adjust the saturation on that. And I want to bring out, I want to take out a little bit of the red that's in there, but we can play around with it. So if we want to increase the saturation to the area that the mask is affecting, we're just going to bring this up, and that's a little bit too much. I just want a little bit there. So now I get the nice blues. It's a little bit purpley. If you want to pull out some of that red, you can click on the red and just pull it back a little bit. Or rather than that, maybe we want to adjust the blues and make it a little more blue. Okay, so let's apply that. Just like anything else, because we're in preview mode, this is showing what it looks like with this saturation stretch applied, or the blue and the saturation. So we're going to null those out, and we're actually going to close that that window, which is the preview window. And then we're going to remove the mask. So you go Mask, right-click on the image, Mask, and Remove Mask. I have a yellow mask that I created. Here's a yellow mask. And again, we're going to do a quick blur on the image, on the mask, and then I'm going to drag the mask onto here. And I'm just going to move the mask out of the way. Let's close that one down. And let's open Curves Transformation, open the preview, maximize it so we can see what we're doing. And again, we're going to go to that RGBK, and if we raise it up, okay, that's the area that we're working on, that bright region. So we can actually add a little bit of contrast to that by clicking on the third bar line here, which is in the highlights. And then in the center, we can just bring it down a little bit. And we can bring the bottom down even more. So you can see the before and after. So that's before, that's after. So let's do that. And you can see it did it again. So we're going to undo that. And then if I wanted to adjust the colors at all, I could just do overall saturation, but I don't want to do that. In fact, I actually want to bring the saturation back a little bit in the center, get rid of some of that yellow that's in there. That's pretty good. Okay, and now I want to do something a little different. I want to work on the outside. So remember, this is the area that we've highlighted. So what I want to do is I want to go back to that. I want to go back to the image. Right-click, go to Mask, and invert the mask. And now the area in red is what's protected. And things that aren't in red are not protected. So if I go back here and I do the stretch the curve, you can see everything's kind of, the outside's really getting whacked out there. So we're going to do a little bit of a contrast tweak on that and the RGBK. And we're just going to bring that down a little bit. That's going to darken up the background. That's good. And we're going to cancel that. And then we're going to go to saturation. And I'm going to bring the low part of the saturation down just a little bit. And bring the highs up a bit. So now you can see those reds in the spiral arms are starting to pop. And the background is pretty neutral. It's not perfect, but it's pretty neutral. So that's pretty good. And let's take that off, close that down. We'll close the preview, and I'm going to right-click, mask, and remove the mask. So you can see it really did a lot. Now, I still want to tweak the contrast a little bit. That center is a bit bright for me. So I'm going to take that yellow mask, and I am going to drag that back on here and go back to Curves Transformation, RGBK, RGBK. There's the preview window. And I want to click on the highlights and the mids and the lows. And we're going to bring the mids down. And that's not quite that much there. And we'll bring the lows down a little bit as well. That didn't help. So what about the highs? Maybe if we bring the highs down a little bit. Look at that. So that kind of made it a little bit less bright in the center. So let's apply that. And actually I like that, so we'll apply it a second time. So let's close that, right click on the image, mask, remove the mask. So now you can see the core here is pretty well defined. There's a lot going on. I'm going to do one last contrast tweak, which is down here, little contrast adjustment, and you can see what that curve looks like. And I'm just going to drag that onto the image. And there, wow, okay. That really did a nice job. I think it did, at least. So there's a lot of detail here in the spiral arms. We've got the colors. And I would actually call this pretty much a finished image. You can keep playing around with this to bring out the spiral arms more. You can make masks. So let's say I wanted to protect the core and work on the outside of the galaxy. So I can go into Scripts, Utilities, Game. And in the Game utility, I can do a add and delete ellipsoids. So I want to add an ellipsoid. And you can see it put an ellipse right here, and it's close to the middle. So I want to kind of drag it out, make it a little bit bigger than the area I want to protect. In this case, kind of like that. So really, I'm just worried about the core, but I want to go a little bit past it because it creates a gradient mask. So I'm going to click OK. And there's the gradient mask. So now, if I take this mask and I drag it onto the image, remember what's red is protected. So I want to invert the mask. So mask, invert mask. So now that you can see the core of the galaxy is really well protected here. So let's go back to Curves Transformation. Okay, so here's our preview image. And just to show you that we have the right area selected, I'm going to make everything brighter. And you can see the outside getting brighter, but the inside still gets a little bit brighter, but not nearly as much. And if I go the other way, you can see that detail's all there, but we lose everything on the outside. So what we want to do is we want to keep maybe just a slight little bit of a curve here, like that. That kind of really brings out the spiral arms a bit more. Again, here's before the stretch, there's after. So it's just a slight change. It does make the background a little bit brighter, but we can adjust that as well. We can do another contrast tweak if we need to. And then again, you can do the colors here. You can, and again, here's another thing. I'm doing multiple things at once. So if I were to accept this change, it would have done the contrast little bump that we did on the spiral arms in the background and the color, but I don't want the color adjusted. So I'm going to X that line. The red X gets rid of the line you're working on. It zeroes out the line that you're working on. But maybe I just want to bring out the blues a little more, and let's see what happens. No, that's not good. That's not good. So let's X that out. And are there greens in the image? Sometimes greens are bad. Sometimes they're not. So in this case, it's not making a difference. But you get the idea. You can really tweak and do all kinds of stuff here to your image. All right, so here's the image. Again, once you're done doing what you're doing, you want to right-click on it, go to mask and remove the mask. Here's that gradient mask, and we can minimize that, get that out of the way. So here's two versions of the same image. Again, this one, I played around a bit more to really bring some of the colors. I didn't want the reds and the blues quite as much as they were here. So I did bring them back a bit. So this is actually my final image that I'm happy with, although I'm never really happy with my images. But it's not perfect, but it's a pretty good image. You can see it's pretty clean. There's not a lot of noise. And there's quite a bit of detail in here. And it didn't take that long. So this is what I would call pretty much a final image. If you want, you could export this as a TIFF or some other format and bring it into a program like Photoshop or Lightroom or GIMP, and tweak the colors and the contrast a little bit there if you want. But I'm pretty happy with this the way it is. So at this point, you can save the file as a TIFF or a JPEG, whatever you want. So hopefully this makes the process a little bit easier for you when you go to do this in the future using Pixinsight. So to summarize the process, the first thing that I had to do was choose my target and the telescope that I was going to use to capture it, configure the image train, then balance everything. Then once it was outside, do a rough focus, get the mount polar aligned. Then once it's polar aligned, do a fine focus, then take my calibration frames. Then in the ASIAIR app, I was able to set up guiding and dithering. Then I captured the light frames using the auto run feature. Once everything was collected, I stacked the images with the Astro Pixel processor, then do the post-processing in Pixinsight to create a final image. That's the whole process right there. Hopefully, this will help you on your astrophotography journey. I'd really appreciate any feedback on this episode. Would you like to see more astrophotography videos? Let me know in the comments. Thank you so much for tuning in. I hope that you found this as much fun as I did. If you have any questions, please email us at astroguypodcast@gmail.com or leave us a text or a voicemail message at 973-404-0380. Please join our Facebook group, the Astro Guy Podcast, and if you subscribe to our YouTube channel, that would be amazing as well. If you could tell your friends about us or leave a review, we'd really appreciate that as well. Tune in for our next episode, which will be out later this month, on what's up in the June 2023 skies. Until then, may your skies be clear, and as always, Carpe Noctem, seize the night. I'm Wayne Zool, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.